Hi guys, today we're going to be doing lesson 32-2, completing the square. Learning targets. Solve quadratic equations by completing the square. Complete the square to analyze a quadratic function. As shown in example B in lesson 32-1, quadratic equations are more easily solved with square roots when the side with the variable is a perfect square. When a quadratic equation is written in the form x squared plus bx plus c equals 0, you can complete the square to transform the equation into one that can be solved using square roots. Completing the square is the process of adding a term to the variable side of the quadratic equation to transform it into a perfect square trinomial. In other words, what we're going to do is we're going to take a trinomial that's not a perfect square trinomial, and by adding or subtracting a value to it, make it a perfect square trinomial. Once we have it as a perfect square trinomial, we can use the square root method to solve. Okay, example A. Solve x squared plus 10x minus 6 equals 0 by completing the square. I'm going to do this a little bit different than the example that is shown, but essentially the same. Basically, in order to do completing the square, remember the square root of the third term doubled has to create the middle term. So what we're going to do, first of all, to figure out what the number is going to be we need, is we're going to divide the middle term by 2. So it's 10 divided by 2 is 5, and then we're going to square it. So that means we want this value right here to be plus 25. Plus 25. And so what we're going to do is we're going to ask ourselves, what do I need to add to negative 6 to get a positive 25? Well, just simply combine those numbers, and we're going to end up with a 31. So that means I have to add 31 to both sides to get that. So that's plus 31 here, plus 31 there. And so what we're going to do is we're going to end up just rewriting the first part of it. And 0 plus 31 is 31. Now what I can do is I can go ahead and factor this, because it is now a perfect square trinomial. I know it's going to be x plus 5 squared is equal to 31. And now it's a problem just like in my last lesson. So I can go ahead and take the square root of both sides. So it's going to be x plus 5 is equal to plus or minus the square root of 31. And then I'm going to get x by itself by subtracting 5 from both sides. So it's going to be x is equal to negative 5 plus or minus the square root of 31. And that's going to be our answer. Try these A. Make use of structure. Solve each quadratic equation by completing the square. A. X squared minus 8x plus 3 equals 11. And so we're going to go ahead and see if we can't get this side to be a perfect square trinomial. In order to do that, I'm going to take this 8, cut it in half. 8 divided by 2 is 4. And then I'm going to square it. I'm going to get 16. So what I need to get is I need to get a 16 here. Positive 16. It's always going to be positive. In order to do that, I have to figure out 3 plus what equals 16. And that means I'm going to have to add 13. And of course, what I do on one side, I have to do on the other. So I just copy this down. X squared minus 8x, 16. And then 11 plus 13 is 24. So this is a perfect square trinomial, so I know it's going to end up being x minus 4. Remember, the first sign is the sign inside here. And that's going to be squared, equals 24. I'm going to take the square root of both sides. X minus 4 is equal to the square root of 24. And it's plus or minus. And so I'm going to end up with x is equal to 4 plus or minus the square root of 24. Now we do have to simplify the square root of 24 if it can be simplified. So we can do that off over to the side if we want. Square root of 24 can be split up into factors of 4 and 6. So that's going to be 2 times the square root of 6. So I'm going to have x is equal to 4 plus or minus 2 times the square root of 6. And that will be my answer right there. B. X squared plus 7 equals 2x plus 8. I need to get the 2x over to the same side as the x squared. So I'm going to subtract 2x from both sides to get x squared minus 2x plus 7 equals 8. Then I look at the middle term. It's a 2. I need to divide that in half to get 1. Square root of 1 is 1. So that means I need this to be a positive 1. In order to make a 7 a positive 1, I have to subtract 6 from both sides. And I go ahead and drop everything down. It's x squared minus 2x plus 1 is equal to 8 minus 6, which is 2. This perfect square trinomial becomes the binomial squared of x minus 1 squared equals 2. Take the square root of both sides. It becomes x minus 1 equals plus or minus the square root of 2. And then I add 1 to both sides. X is equal to 1 plus or minus the square root of 2. Completing the square is useful to help analyze specific functions of quadratic functions, such as the maximum or minimum value or the possible number of zeros. When a quadratic equation is written in the form y equals a times x minus h squared plus k, you can determine whether the function has a maximum or minimum based on the value of a. If a is positive, it has a minimum. If a is negative, it has a maximum. And what the value is based on k. So that would give us the minimum or the maximum. This information can also help you determine the number of x-intercepts. Example B. Analyze the quadratic function y equals x squared minus 6x plus 13 by completing the square. So in this case, we're analyzing. We're just going to leave the y here. So it's going to be y is equal to x squared minus 6x plus 13. And we want to make this trinomial a perfect square trinomial. So we have to think to ourselves, well, let's see. The middle number is a 6. Cut it in half, it's 3. 3 squared is 9. So I want this constant term to become a 9, positive 9. So in order to get 13 to become a 9, we have to subtract 4. But what we do on one side, we also have to do on the other. So we end up with y minus 4 is equal to x squared minus 6x plus 9. And this perfect square trinomial becomes the binomial squared of x minus 3 squared. So we end up with y minus 4 is equal to x minus 3 squared. And then if I want to go ahead and get y by itself again, I have to add 4 to both sides. So I now get it to be y is equal to x minus 3 squared plus 4. And if you remember, that's in vertex form. We can pull the vertex out by looking at the vertex with these two numbers here. The vertex is going to be positive 3, positive 4. And that'll help us determine the minimum value or the maximum value based on a. In this case, a is equal to positive 1. So therefore, it has a minimum value of 4. One thing to note, if this has a positive a value, which means it's a happy flower, it's opening upward, then, and it has a minimum value that is positive, minimum equals 4, that means it will not cross the x-axis at all. So therefore, there are no solutions. Try these B. Write each of the following quadratic functions in the form y equals a times x minus h squared plus k. Identify the direction of the opening, the vertex, the minimum or maximum, and the number of x-intercepts. Okay, so let's go ahead and try these A. It's going to be y is equal to x squared minus 4x plus 9. So we're going to start off by completing the square. We look at the middle term, cut it in half. 4 divided by 2 is 2. We take the square root of 2, we get 4. So that means I want this to have a 4 at the end. In order for that to happen, I have a plus 9, I need it to be a plus 4, so I have to subtract 5 from both sides. Okay. So let's just rewrite it. That's going to be y minus 5 equals x squared minus 4x plus 4. This perfect square trinomial becomes x minus 2 squared. And so it's going to be y minus 5 equals x minus 2 squared. And then we'll go ahead and add 5 to both sides. So we get y is equal to x minus 2 squared plus 5. Now we can analyze the information we have here. First of all, because the a value is positive, a is equal to positive 1, it's going to be an upward opening or a happy flower. So therefore it has a minimum, and the minimum value is 5. Because the minimum is positive, it'll never cross the x-axis, so therefore there are no solutions. Or no x-intercepts. Remember, the vertex is going to be, remember we use an opposite value here, so it's going to be 2, 5 is going to be the vertex. So the vertex is the point 2, 5. It's going to be opening upward. So therefore it has a minimum value of 5. And no x-intercepts or no solutions. B. It's going to be y is equal to negative x squared minus 6x minus 8. And in order to get this started, so I can do a perfect square trinomial, that has to be a positive x squared. So therefore I'm going to go ahead and multiply both sides by negative 1. And that changes all the signs. So we have negative y is equal to x squared plus 6x plus 8. Now this is not a perfect square trinomial. In order to make it a perfect square trinomial, I need to look at the 6, cut it in half, it's 3. 3 squared is 9. So I need this to be a 9. So to get from 8 to 9, I have to add 1. And what I do on one side, I have to do on the other. So I have negative y plus 1 is equal to x squared plus 6x plus 9. Now I can rewrite this perfect square trinomial as a binomial squared, x plus 3 squared. And so that's going to be negative y plus 1 equals x squared, x plus 3 squared. And then I'm going to subtract 1 from both sides. I'm going to get negative y equals x plus 3 squared minus 1. Now the last step is to get rid of the negative y. So I'm going to go ahead once again, and I'm going to multiply both sides by negative 1. So that's going to be a positive y is equal to negative x plus 3 squared plus 1. And so that's our answer in vertex form. Now in this case, if you're noticing what we have here, a is equal to -1, so therefore it's opening downward. Okay, our vertex is at -3, +1. Okay, because it's the opposite of this sign here for the x value of the vertex. All right, and so if we think about where this is going to be, it's going to be at the maximum value of 1, and it's going to be going down. So it's higher than the x-axis, it's going towards it, so there's going to be 2 solutions, or x-intercepts. Okay, C. C is y is equal to x squared plus 8x plus 15. And so I want to convert this to a perfect square trinomial. I want the x value here, let's see, 8 divided by 2 is 4, 4 squared is 16, so I want this to be 16. So 15 plus 1 is equal to 16. I'm going to add 1. So it's going to be y plus 1 is equal to x squared plus 8x plus 16. I'll rewrite the perfect square trinomial as a binomial squared. It's going to be x plus 4 squared. And then I'm going to get y by itself by subtracting 1 from both sides. So y is equal to x plus 4 squared minus 1. So a is equal to 1. So therefore, since 1 is positive, it is opening upward, so it has a minimum value. That minimum value is -1. The vertex is at -4, -1. So remember, it has a minimum value that is below the x-axis, and so it's going to be opening upward, which means there's going to be 2 solutions or 2 intercepts. I check your understanding. Item 1. X squared plus 2x plus 3 is equal to 0. We want to make this a perfect square trinomial. We look at the b value, which is a 2. We divide that in half, we get a 1. 1 squared is 1. So I want to get my 3 to become a 1, and I do that by subtracting 2. And what I do on one side, I have to do on the other. So the rest of these I kind of just drop down. X squared plus 2x plus 1. And that's going to equal -2. So now as this perfect square trinomial, I rewrite it as a binomial squared. So it's x plus 1 squared is equal to -2. I take the square root of both sides. And we end up with x plus 1 is equal to plus or minus the square root of -2. But since we have a negative in the radical, or inside the square root sign, there's no real solutions. Because we don't know in the real number system of a number that when we multiply it times itself to get a -2. So the answer here is no real solutions. All right, so item 2. Item 2 is x squared plus 6x plus 4 equals 0. Again, we're trying to make this a perfect square trinomial, so we look at the middle term, and the b value is 6. Cut 6 in half, we get 3. Square 3, and we get 9. So that means we need a 9 down here. So in order to get a 9, we have to add 5 to both sides. So we end up with x squared plus 6x plus 9 is equal to 5. This becomes x plus 3 squared equals 5. When we take the square root of both sides, it'll be x plus 3 is equal to plus or minus the square root of 5. Subtract 3 from both sides. We get x is equal to negative 3 plus or minus the square root of 5. And the square root of 5 cannot be simplified further, so we leave it like that. Okay, the rest I'm going to leave for you to do for homework. Remember, if you have any questions, you can come to virtual tutoring on Zoom weekdays at 3 o'clock.